Section 6.5. We're going to look at some special factoring formulae. What's formulae? Yeah, formulae is the plural of formula, not formulas, although you will see formulas written everywhere today. The correct answer is formulae. All right, so remember we built this chart the other day. I'm going to build it again. You see the word factor. Anytime you see the word factor, what's the very first thing you're going to do? Look for GCF. Look for your greatest common factor. That's always the first step. What's the second thing you do? Well, yeah, if they're not in order, you always put them in order. That's a default. That doesn't matter if the directions say factoring or not. If they're not in order, you always start by putting them in order. What do you do after you deal with your GCF? You count how many pieces there are. And what do you do if you see 4 pieces, 4 terms? 4 terms, factor by grouping. What do you do if you see 3 terms? You look at the leading coefficient. You look at the very first number. If the very first number is the number 1, what do? Guess and check. You do the FOIL backward. So you have 2 choices here. Guess and check. And generally you use that when the leading coefficient is 1. And your other option is, what if the leading coefficient is not 1? You do what we just did, which is you multiply the ends, you try to find a number that works. That was called grouping. And you generally do that when the leading coefficient is not equal to 1. All right, and here's the new thing. If you have 2 terms, look to match a special formula. And we are going to have 3 of them. We're going to have 3 special formulas. The first one we've already seen. First one is called difference of squares. We saw this a few sections ago, and we noticed that this just worked out. If we multiplied a plus b and a minus b, so we noticed the things in the parentheses were the same, except one had a positive, one had a negative, and we had a name for that. Anybody remember the name for that? And the things were the same, but one was a positive, one was a negative. Starts with a C. Got a J in it. Close. Conjugate. Those were called conjugates. What happens when you multiply conjugates? You do get a negative, but you get other things too. Well, let's just FOIL it out and see. What's A times A? A squared. Minus AB. Plus AB minus B squared. And what happens? Something nice happens. The middle things cancel out. And you're left with A squared minus B squared. And this formula is called difference of squares. Why is it called difference of squares? What does difference mean? Subtract. So we're subtracting, and the 2 things are both squares. Okay? So, as a factoring formula, this is usually written this way. A squared minus B squared equals A plus B times A minus B. Back when we did this a few sections ago, we were dealing with multiplication, so we started with a plus b, a minus b, and we wrote it that way. As a factoring formula, generally you write it backward. If you start with a squared minus b squared, it's going to factor as a plus b, a minus b. Some examples. X squared minus 16. And again, the directions here are factor. The directions are always factor in this chapter, it seems. I see the words factor. The very first thing I do is I look for a greatest common factor. Is there a greatest common factor? No, there is not. Second thing I do is I count the number of pieces. How many terms are there? There are 2. So now you ask yourself, does it fit into a formula we know? Well, at this point, the only formula we know is square minus square. Does this one fit square minus square? Yes. In fact, it's x squared minus 4 squared. 16 happens to be 4 squared. So that's going to factor how? X plus 4, x minus 4. I heard some people saying x minus 4, x plus 4. Does it matter which one you put first? No, why not? What's that? Organized by order? True. But how come it doesn't matter if I switch the order? How come I can put the x plus 4 first or second? Because it's the same answer? Because I'm looking for a special property. Begins with a C. Commutative property. The commutative property of multiplication says I can change the order, can't I? So I can write the x plus 4 first, or I can write the x plus 4 last. It doesn't matter. All right, how about factor 3x squared minus 12? How do you factor 3x squared minus 12? First, you look for a greatest common factor. The greatest common factor is 3. You're left with x squared minus 4. So now you look at what's left. What's left is x squared minus 4. That has 2 terms. Does x squared minus 4 fit into our square minus square formula? Yes, because 4 happens to be 2 squared. So our final answer, we're going to have the 3. And then we're going to have x minus 2. And then x plus 2. Questions on that one? All right, last one of these. How about factor x to the 4th minus 16? Is there a greatest common factor? No. There are only 2 pieces. Does it fit into our square minus square? It does if you're clever about it. It doesn't look it, does it? Because it looks like that power is a 4. But it really does work. How come? I can split it up how? Correct. X to the 4th, you could think of as being x squared squared. Because when you have a power followed by another power, what do you do with those powers? You multiply them. Minus 16 happens to be 4 squared. So this really is something squared. It's just that your something squared happens to be x squared. That's okay. Minus 4. So that's going to be x squared minus 4, x squared plus 4. However, you're not done. X squared minus 4 can be broken up more, because that's a square minus 4 happens to be 2 squared. So that's a square minus a square. I can break that up more. That's x minus 2, x plus 2. How about x squared plus 4? Can I break up x squared plus 4? No, I can't. Why not? because I won't get the right answer. All right, so that was kind of a trick question. You won't get the right answer. All right, so x squared plus 4. Notice that this is a square plus a square. 4 happens to be 2 squared. A square plus a square will never factor. And a lot of people want it to factor and it won't. So let me just show you what I mean by you won't get the right answer. A lot of people want x squared plus 4. They'll think that it factors as x plus 2 and x plus 2. That's not the right answer. How come x plus 2 is not the right answer? Because you have the middle. When you FOIL this out, you get x squared plus 2x plus 2x plus 4. You get x squared plus 4x plus 4. Those are not equal. All right, so that's one to watch out for. X squared plus a square is always going to be prime. So if I asked you to factor x squared plus 9, you should tell me the answer is prime. A square plus a square will never factor. That one's prime. So watch out for that. It's a very, very common mistake that I'll see.
So you mean as far as the unit would be like broken into two parts?
Correct. It cannot be broken into two sets of parentheses. Absolutely correct. It's prime. All right, so that was our first formula. Our first formula was difference of squares. Then we have two more formulas that are very, very similar. One is called difference of cubes. And one is called sum of cubes. So sum of cubes looks like this. You have something cubed. Did I say sum? I meant difference. Difference of cubes looks like this. You have a cubed minus b cubed. And the way this is going to factor, this is going to be a minus b, a squared plus ab plus b squared. So you can either just trust me that that's right, or if you don't believe me, what you can do is take a minus b and distribute it through and see that you do get a cubed minus b cubed. Those are your two choices. You can either believe me, or you can go ahead and try it and make sure I'm not lying to you. Pretty sure I'm not lying to you. And then the formula for sum of cubes looks very similar. A cubed plus b cubed. This one will factor as a plus b, a squared minus ab plus b squared. So those are two formulae you need to simply go home and memorize. You have to know those. If you don't know those, then you can't do the problems. It's as simple as it is. All right, so these problems are going to look like this. Factor. X cubed plus 64. First thing you do is you look for your GCF. What's the GCF? What is that? No, there's no 8 in the first piece. There is no GCF. The next thing you need to recognize is that there are exactly two pieces. When there are two pieces, you need to see if it fits into a formula. Does it fit into a formula? Sum of cubes is x cubed plus 64 happens to be a nice number. 64 is 4 cubed. So this is x cubed plus 4 cubed. 64 happens to be 4 times 4 times 4. All right, so what I kind of like to do is I kind of like to write this a cubed plus b cubed. I kind of like to write it underneath. It's going to be a plus b times a squared minus ab plus b squared. So in this case, what's A? A is just X. Wherever I see the letter A, I'm going to use the letter X. And wherever I see the letter B, what am I going to use? Just the number 4. So A is the letter X, and B is the number 4. So I'm going to have A plus B. That's X plus 4. Times A squared. What's A squared? X squared. Minus AB. What's AB? X times 4, which we would probably write as 4x. Plus, what's B squared? 4 squared, which is 16. Questions on that?
That's it? All you have to do? If you have to, that's all you have to do?
All right, well, let me ask you a question. Maybe that's all I have to do. What I notice here is I have this one over here, which has 3 pieces. I should try to factor that one, shouldn't I? How do you factor x squared minus 4x plus 16? Guess and check. Okay, so it would have to be x and x on the front. How can I get 16 on the other end? Well, I could use 1 and 16. Can I get a 4 out of a 1 and 16? No. I could use 2 and 8. Can I get a negative 4 out of a 2 and 8? No. I could use 4 and 4. Can I get a negative 4 out of a 4 and 4? No. So that piece is prime. So we've done the best we can do. That trinomial on the end there doesn't factor. And I'll save you a small amount of time. When you use these 2 formulas, difference of cubes, sum of cubes, this trinomial you end up with on the end, it will never factor. It will always be prime. So you don't have to try them anymore. I promise you it'll always be prime.
Difference of two?
For either one. For difference of cubes, you end up with that trinomial. For sum of cubes, you end up with that trinomial. Every time they will be prime. Those trinomials that you're left with will never factor. So you really don't even have to try them anymore. That's correct. All right, last one of these. How about 100x cubed minus 27? Again, we begin by looking for the GCF. No GCF. Does it fit one of our formulae? Difference of cubes, because 100 happens to be 10 cubed. 100 is 10 cubed? No? Yeah, I copied it wrong. Let's make it 1,000. 1,000 happens to be 10 cubed. That's better. Well, what if it were 100 there? Our answer would be, does it fit into any of our formulae? No, so what would our answer be? Prime. Our answer would have been prime. All right. I wanted it to be 1,000 though. All right, so 1,000 happens to be 10 cubed. So this first piece I'm going to write as 10x whole thing cubed minus 27 happens to be 3 cubed. So again, I like to kind of write the formula here. A cubed minus b cubed is going to factor as a minus b times a squared plus ab plus b squared. In this case, every time I see the letter A, I'm going to write, not X. Every time I see the letter A, I'm going to write 10X. And every time I see the letter B, I'm going to write 3. Well, the minuses are taken care of by the formula right there. Okay? So A, we decided A was 10X. Minus, we decided B was 3. That's going to be 10x minus 3. A squared. What's a squared going to be? All right, when you say 10x squared, do you mean 10x squared? Like that? Or do you mean 10x squared like that? And those are very different, aren't they? This one is 10x squared. This one is 100x squared. Which one do you mean? The bottom one, that's correct. A is the number 10x. So whenever I see a 10x, I need to square it according to this formula. So it really should be 100x squared. And again, I'll see a lot of people write 10x squared there. It really should be 100. You got to square the number and the letter. Plus a times b, that's 10x times 3. You're going to write 30x plus b squared is 9. Same thing. That trinomial over there will be prime. You can try to factor if you want to. But I promise you, you're wasting your time and effort. That's the best answer we can do right there. All right, the last thing that shows up in this section are problems like this. Let's see if I can find one. Do they have one here? I don't really see one like I want, so I'm going to make one up. How about 25x squared minus 20x plus 4? How would you normally factor that one? By grouping. You would notice there is no common factor. You would notice there are 3 pieces. So normally you would factor by grouping. Here's another little hint, something to watch for. This will work sometimes it won't. But when it does work, it's really nice. Something to watch for is the first number, 25, happens to be something special. What's 25? It's 5 squared. And the number on the end also happens to be something special. What's the number on the end? 2 squared. So, if I see a square on this end and a square on that end, I'm going to try the guessing method. And what I'm going to guess it's got to be 5x and 2 and 5x and 2. If I use 5x and 2 and 5x and 2, can I make it work to get a negative 20 in the middle? Yes, make them both negative. And you can do a quick FOIL and see that works. It does work because you get negative 10x. Negative 10x makes negative 20x. So that's just a shortcut little thing to look for. How often does it happen? Not very often. It's not very often that you have a square on this end and you have a square on that end. But when you do, when you have a square on this end and a square on that end, a lot of times it's going to work out that way where 25 was 5 squared, so 5 and 5. 4 was 2 squared, 2 and 2. Write your numbers down, try your sign, see if you can make it work. Not going to happen very often, but when it does, it's a pretty big time saver. That's a lot quicker than using the grouping method.
So is there going to be a time where we absolutely have to use the decimal method? Or you don't have to? It's just...
You don't have to. The only time I highly recommend it, again, when that first number is 1. So if it's x squared minus 4x minus 12, the grouping method will work. You can multiply the 1 times the negative 12 and get negative 12, split up negative, and get, the grouping method will work. But I think the guessing method's a lot faster. So that's the only time